Section 8.2 is the law of cosines. So a reminder that the law of sines can be used on triangles when the known parts are two sides and an angle opposite one of them, so side-side angle, or you have two angles and any other side, so angle, angle, side, or angle, side, angle. The law of cosines now can be used on an oblique triangle given two sides and an angle between them, so side, angle, side, or if you're given all three sides, so side, side, side. And here we have the law of cosines, and if we were in class, I would go over a relatively short proof for these, but since we're doing this on video, we are just going to jump into the problems. So solve triangle ABC, given that A is 5, C is 8, and beta is 77. Please pause the video and draw the triangle that represents this. So here we have our triangle, and it is important that you remember that when I have side A, angle alpha has to go opposite that. When I have side C, angle gamma has to go opposite that. And when I have angle beta, side B has to go opposite that. And so now I would like you to, we have two sides and an angle between them, so I would like you to pop these into the law of cosines. So there we have them plugged into the formula, and now I can just square and multiply together to simplify a little bit. And my first step of simplifying, so now I get that b squared is approximately 71, which means b is approximately 8.4. And now I could use the law of cosines again, but I also just want to remind you that we could use the law of sines. So I could now also say that the sine of alpha over 5 equals the sine of 77. And one reason I want to do this is because I don't want you to use 8.4. You should always use exact answers if you're able to. So you should actually use the square root of 71. And now I'd like you to go ahead and solve this for alpha. The sine of alpha is 0.5782. So using the inverse sine, I can find that alpha is approximately 35 degrees. And now remember, the sine is positive, so the sine can occur in the first or second quadrant. But in order to get this angle, I would have to take 180 minus 35 degrees. And if I did that, then I'm not going to actually have a triangle because the three angles of my triangle also have to add up to 180. So I'm not going to consider that other triangle, or that other angle. And so now I have angle alpha, and now I just need angle gamma. And remember that, as I just said, the three angles have to add up to 180. So I'm going to take 180 minus 77 minus 35, and I get that angle gamma is 68 degrees. Example 2, if ABC has sides A is 90, B is 70, and C is 40, approximate the angles alpha, beta, and gamma. So again, please pause the video and draw your triangle. And again, it is important that you label your triangle correctly. Remember that across from side A has to be angle alpha, across from side B has to be angle beta, and across from side C has to be angle gamma. And these are critical when it comes to plugging them into the formulas, that you have them in the right orientation. So now, I would like you to please use the law of cosines and plug those in and try to solve for one of the angles. I'm going to do it alphabetically, so I'm going to solve for angle alpha to begin with. First of all, just plugging the values in. And now go ahead and square and multiply and simplify those a little bit. And that's what I have in my first step, just squaring them. And starting to move things away from my cosine of alpha. And the cosine of alpha is negative 0.2857. So now using the inverse cosine, I'm going to find that my alpha is 106.6 degrees. It wants it to the nearest degree, so alpha is 107 degrees. Now, just for more practice using the law of cosines, I'd like you to pause the video and try to use the law of cosines to find angle beta. First plugging the values in, and now we're going to square them and multiply. And now let's solve for the cosine of beta. And now taking the inverse cosine of each side, I find that beta is 48.2 degrees. Again, rounding to the nearest degree, I'm going to record that beta is 48 degrees. And then finally gamma, we have 180 minus 107 minus 48 degrees means that gamma is 25 degrees. Example number 3, a parallelogram has side lengths 30, 70, and one angle measure of 65 degrees. Approximate the length of each of the diagonals to the nearest centimeter. Again, please pause the video and draw your parallelogram and label it. Here's my parallelogram, and I need to find the lengths of both diagonals. So I'm going to draw that diagonal in there, and I'm going to label it A. And now if you notice, I have two sides and an angle between them, so I can go ahead and use the law of cosines to find length A. So please go ahead and pause the video and set that up. And now I'm going to do my squaring and multiplying together to simplify this a little bit. And now it's a matter of putting the right-hand side into my calculator, and I find that A squared equals 4025.003301. When I take the square root of both sides, I get that A is approximately 63.4. It wants us to approximate to the nearest centimeter, so that first diagonal is approximately 63 centimeters. Secondly, we need to remember that the angles of a parallelogram, of a quadrilateral actually, add up to be 360 degrees. So to find this angle measure, so that I can also use the law of cosines to find that diagonal, which I'll call B, we're going to remember that 360 minus my two 65 degree angles leaves us 230 degrees, but that 230 degrees has to be split among those other two angles, so each one is a 115 degree angle. And now again, please set up your law of cosines to find what that second diagonal B is going to measure. So again, I've used the law of cosines to set this up, and now I'm going to find that B squared equals 7,574.996699. And I take the square root, and I find that B is approximately 87 centimeters. So those are my two diagonals. Example 4, a vertical pole 40 feet tall stands on a hillside that makes an angle of 17 degrees with the horizontal. Approximate the minimal length of cable that will reach from the top of the pole to a point 72 feet downhill from the base of the pole. So first of all, I'd like you to draw the picture. So stop the video and see if you can draw the picture for this situation. So this is the situation I have. I have a 40-foot pole. It's on the top of a hillside that only makes a 17-degree angle with the horizontal. And this distance here, the base of the pole to the bottom where I want my cable to reach, so this is the distance that I need to find. And we know that the length of the hill from the base of the pole to the bottom of the hill is also 72 feet. So now I need to find that angle. So in order to use the law of cosines, I'm going to need to know what that angle is. Well, fortunately, this triangle down here, if I draw this down, this was the horizontal. Since this is a right angle, I know that the angles of this first triangle, bottom triangle, have to add up to 180 degrees. So I know that this angle is going to be 73 degrees. Angles on a straight line add up to 180 degrees. So that angle down in the corner that I need is actually a 107 degree angle. Now I'd like you to pause the video and set up your law of cosines to find out how long that cable needs to be. And here we have plugged everything into our law of cosines. And so now we just need to square our numbers and simplify the right-hand side. Simplifying this a little bit, and then when I plug this into my calculator, I'm going to get that x squared equals 8,441.747566. And when I take the square root, I see that I get x is approximately 9.91.87. So I could say that my cable needs to be about 92 feet long. And next, the area of a triangle can be found without necessarily knowing the base and the height. We know the area of a triangle is 1/2 base times height, and if we don't know the base or the height of our triangle, how could we find the area? Well, now we can without actually knowing what that vertical height is or that perpendicular height is. So now I want you to use this formula. One thing I'd like to point out about this formula is that to use this formula, you need two sides and the angle between them. I'd like you to go ahead and use this formula to do example number 5, please. By drawing this triangle out, and labeling it correctly, I can see that I do have two sides and the angle between them. So in this case, I can just plug these right into that formula. So please go ahead and do so. Plugging those values into the formula, and now it will be a matter of plugging this into your handy-dandy calculator, and you can see that the area is about 0.9789. We could round this to about 0.98 centimeters squared for the area. Example number 6, approximate the area of this triangle ABC, given A is 5, B is 3, and alpha is 37. Again, please pause the video to see if we have the right information. Draw your picture. So I do not have the right information. I actually, since I'm given these two sides, I need angle gamma. So let's see if we can find angle gamma. The sine of gamma over, I can't use the sine of gamma over c. That would give me two variables. So let's instead do the sine of beta over 3 equals the sine of 37 over 5. Now let's go ahead and find our beta. You see that the sine of beta is 0.3611. Taking the inverse sine of both sides, I get that beta is 21.2 degrees. And again, I can't use the ambiguous case. If I tried to use the ambiguous case, then I wouldn't be able to form a triangle. So now moving on from here, my gamma is going to be 180 minus the 37 degrees minus 21.2 degrees. So my gamma is 121.8 degrees. And now that I have alpha or angle gamma, I have two sides and an angle between them. Go ahead and approximate the area of this triangle. Plugging those in, I can see that the area is going to be 7.5 times the sine of 121.8. And plugging that into my calculator, I get 6.3742. So I could approximate the area of this triangle as having 6.4 square centimeters. Heron's formula also allows you to find the area of a triangle, except you only need the 3 side lengths. This is extremely useful, especially in property. So if I can measure, as the example for 7 is, I'm given a triangular field with side lengths of 125 yards, 160 yards, and 225 yards. I want to know how many acres I would have, and you're given the conversion for the acres. The one thing about this formula is we have this S, and S is 1/2 of the perimeter. So add up all the sides and divide it by 2, and you'll have your S. So let's go ahead and do this first problem. The first thing, obviously, you're going to need to do is find your S. So please pause the video and do so. 1/2 of the sum of all the sides is going to be 1/2 of 510. So my S is going to be 255. And now please go ahead and pause the video again and plug all those correct numbers into your formula. There we have them all plugged in. Now let's simplify each of those parentheses, and then multiplying them all together. And finally, taking the square root, I have that the area is approximately 9,720 square yards. I believe it comes out to 9,719.95, so we're just going to round it to the 9720. Now I need to put it in terms of acres, so 9,720 divided by 4,840 square yards in an acre gives me that this is 2.0083. That means I have about 2 acres. If you have any questions on these problems, please make sure you come to class. I look forward to seeing you there.